In this video, I'm going to show you how to use the array module in Python. This is a very useful module, and it's a different data structure that you can use. So most people are familiar with lists. You can call them as a function, or you can use the literal brackets notation. And it's a very well-known data structure. It has a lot of useful methods like .append and .pop and extend and insert. And lists are very good for dealing with data. But if you have a large amount of numerical data or Unicode data and you want to operate on that, you're probably going to want to use an array. If you're doing this kind of work, you probably are already using NumPy arrays though, but if you're not, then you should use these arrays for sure. They're very useful and they have a lot of extra methods that can really help out and are much faster because they are there's just C arrays, if you're familiar with C arrays. So I'm going to import the array module, and array has two main functions, I guess. So there's array.array and array.typecodes. So there's also an array.array type, but it's just an alias to array.array, as you can see from here. It's just the same thing. And there's also some weird array.reconstruct array, something like that, but that's just an implementation detail. You don't have to worry about that. So let's see. So first, an array.array takes in two arguments. The first one is a type code of the type of elements you're putting into the array. So there's three options, three like general options you can do. You can use floats, ints, or strings. So if you're doing strings, it's the U type code, and int has a bunch of different ones like H and I think Q or something, I don't know. And in like most of these cases, lowercase means that, I'm not sure if it's unsigned or signed, but it means that I'm pretty sure it means that you can have positive and negative numbers. But if you use an uppercase, you can only use positive numbers, but it's like double the amount than if you didn't. Whatever. It's like, if it shouldn't really affect you much. But for floats, you would use either F or D. F is regular floats, and D is double precision floats. So let's look at, first, before we do that, we can see all the type codes like this, actually, and we see with B, lowercase and uppercase b for signed and unsigned. This is the string type, Unicode. These are more of the uppercase and lowercase types for integers, and the different type codes mean like the amount, the limit of the numbers, like the length of the numbers that you can put into the array, because some numbers take up more space than other numbers. So if you put a number that can't fit into the array because it's too big, I think it will just raise an error, I think. So I think here, let's see. So if I have an array.array, here, let's see, r equals array.array h. I think h is the smallest one. And let's just have some like big numbers like that, maybe even bigger, and just to the power of 20, I don't know. So the second argument, by the way, is an iterable that will be stored in the array. So I don't think this will work. Yeah, you get an overflow error. It's greater than the maximum because this is a signed short integer. So when it's lowercase, it's signed, which means you can use positive and negative, and if it's uppercase, it's unsigned, and you can only use positive. Okay. So that's that. So I'm going to show you all the methods of an array.array that's using the f-type code for floats. So I'm just going to load it up with a bunch of numbers. Okay. And we could check it out like this. Simple. Okay. And we could also get the type code like that, which is f. And we could also check out the size of, we could also check the item size, which is 4. So each item gets 4 bytes. And I'm pretty sure with an array that has D, each item gets 8 bytes, I think. So yeah, 4 bytes. 4 bytes is a lot compared to the other type codes. Some of the type codes could only take 1 byte or 2 bytes. So 4 bytes could be a lot, but if you really need to deal with floats, then it should be fine. You mostly don't have to worry about memory, but if you do, then I don't know, you could take this into account. Then there's the buffer info function, method, whatever, and it shows you the address in memory and I think this is the length of the array, so 9 elements. I think that's what it means. And then there is the byte swap method, which does something, I don't know, like swaps bytes, I guess. I'm not exactly sure what it does. It just gives you some of this. But if you want the original back, you just byte swap back. So I don't think there's I can't think of any real use for this. I think the documentation says that it's useful for like reading from files that have like different byte ordering or something like that. So if you're dealing with that, then you can use this, I guess. Then there's the count method, where you could count how many of something is in it. So because we only have 1 of each of these numbers, it's gonna just give us a 1. Right? And if we give it something that we don't have, it's going to give us a 0. Okay. Then we have extend. Count and extend are also list methods too. So I'm just going to go over them anyway. And we can extend a list or any iterable to this array with more floats. And we don't even have to specify as floats, by the way, because it will just be transformed into floats. So if we check out R, it extends them and it automatically transforms them into floats for us because of the float type code. Okay. Now we could also check the index of any of these floats. So if we want to check where 1.0 is, it's at index 0, and we could also give it a start and stop to look through. So if we want to look through 0 and 5, then we'll give it to us, but if we make this 1 through 5, it's going to raise an error that's saying X is not an array because we are only looking through the first index element through the 5th. And then there is insert. So we can insert, so we first insert the position, and then I think this, whatever you put next, will be put before that position. So let's try 1.1, and yeah. So you can see how this 1.1 is all messed up. That's because of if we put this as a D, I think it would be more precise to be zeros. But because it's not, it just makes some random garbage because of floating points and all that. Then we have pop, so we could pop the last number if we don't provide anything, and it will return it to us, and now it's gone. Or we could provide a specific index like this, and now it's like that. Now we have the remove method. So we could remove a specific number from it. So we want to remove the 12. Now the 12 isn't in there. And notice that the 12 is not returned to us either. Because, I mean, if we're specifying it, it doesn't really need to return it to us. And then there's also the reverse method, which reverses it. And let's just reverse it back for now, because now we're up to the methods that go to and from certain things. So we have 4 of these. We have to and from bytes, to and from files, to and from lists, and to and from Unicode. So let's first look at bytes. So if we want to change it to bytes, well, there's your bytes. The array is unchanged, but this is how the bytes would look like. So if we want to take the bytes like this, we could. There we go. And those are the bytes. And then there's from bytes. So I'll show you how that works. So let's say we have an array 0, which is an array, and we're going to specify the same type code. We can use the class method from bytes to get the array bytes. And now we have the exact same array. So it just reads from the bytes. So if you're dealing with bytes and stuff, then that could be useful. And they are the exact same thing also. But they're not the same, but they have the same elements. Okay. Then we have to and from file. So to do this, you're going to have to open a file with the with statement, or, I mean, you don't have to, but it's better to. And I'm going to open up some file, example.txt, and you have to do this in write binary mode, or else you'll get an error. Make sure to remember to put the B here, because we are writing the bytes of the array into this text file, because it's much faster, like that. Oh, oops, I made a mistake. I should get the file. Yeah, that would be bad. And now we are going to use the toFile method. So r.toFile fp. And now saved in this file that I just opened and created, there are the bytes of this array. Now, if we want to access these bytes with a different array, we could. So I'll show you how to do that. So an array.array, type code f, okay, and we're going to use the from file method. Let's open the file first. That's probably a good idea. And remember to add b, read binary, and remember to get the file as well. And now I'm going to use the class method from file fp, and you have to provide a second argument with the amount you want to get. So I think our previous array was maybe, I think it was 11 elements long. I'm not exactly sure. So we would get these. Yeah, so now we could check that all of these arrays that we've saved in different ways, they're all the same. And these are extremely fast compared to using lists. So if you're doing this kind of stuff, then this is much more efficient. And speaking of lists, we are going to show the toList and fromList methods. So I'm going to say our list is array r.toList. I think this is how it works, yeah. And now we have it as a list. And now if we want to get the array, get an array from a list, we can do that like this. Very simple. And we just say from list, and you have to specify the list, obviously. And it's the same thing. And finally, we have from into Unicode. So we didn't really talk about the Unicode one so much, but let's say we have an array of Unicode Unicode string. So we would specify it with the U type code, and now you just give it a string of something. So I don't know, just say wow. Okay, and that's it. So it's just basically a string, but it's an array. See, if you like get items, whatever, it's just an array, but with a string inside of it, basically. I don't know why that's any more useful than a string. Maybe it's faster. But what you can do is you can use the toUnicode method to turn it into a string. And here, let's actually get that. ru.toUnicode. There. And now we could make an array from that. So let's make ru0 is an array like this, and we can use the from Unicode here, and they're the same thing. Okay, that's basically it with arrays. This is a bit of a long video, and I hope you watched the whole thing, and thank you, and see you soon.